Starting with the name of Almighty Allah, who is Rahman and Rahim. We are going to present our final year project, which is titled as PV-based DC to AC inverter design for home using MATLAB, using LabVIEW and NI Multisim. This project has been supervised by Dr. Fahim Akhtar Chachad, HOD Electrical Engineering Department, Kharabi University, and co-supervised by Engineer Mahmood Mughal. We are 3 students in our team, Imran Ali, Tajar Adil, and V. Saifullah. Outline of this project as introduction, problem statement, motivation, aims and objective, literature review, methodology, results and discussion, conclusion, future recommendation, and references. Problem statement. The world of electrical energy is constantly increasing. As we know that the need of electrical energy is constantly increasing. Conventional energy resources are going to be diminishing or even threatened to be depleted. Prices of electrical energy are rising day by day. Energy generation is facing a big challenge for meeting the load demand during the peak hours. Solar produces direct current DC and it's very cheap to produce as compared to the electrical energy. Motivation. Solar energy has proved to be very promising alternative because of its availability. In order to mitigate pollution caused due to excessive use of fossil fuels based electricity generation, this is also a clean energy. We can say microgrid utilize renewable energy. This is the big motivation to design this project. Due to increasing efficiency and decreasing cost of PV cells, less maintenance is required in solar energy. Aims and objective. Study involving design and integration of inverter with PV, learning different tools, LabVIEW, Multisim, and FPGA, simulating a 3-phase inverter using NI Multisim and NI LabVIEW, design PV-based 3-phase inverter for homes, modeling and simulation of DC to AC converter, inverter and Multisim, modeling and simulation of control design and LabVIEW, modeling the LabVIEW Multisim co-simulation for PV system integration, analyze the power quality of designed inverter, the power efficiency and power losses and switching losses during the conversion process. Introduction. This FIP is based on the simulation of 3-phase grid-tied inverter using NI Multisim and NI LabVIEW software. We have designed it with NI Multisim and NI LabVIEW, and we have used their co-simulation model. Multisim and LabVIEW enables code design of an entire system, ensuring that algorithm and code simulated for the field programmable gate array, FPGA, and LabVIEW are verified for real-time performance with analog circuitry that has been tested in field lab. Introduction. Sinusoidal PWM has an extremely famous method utilizes as part of AC control. The technique that has been used in this project is SPWM technique. We have compared sawtooth wave and sine wave, and we have generated a reference signal in order to give the PWM signal to the MOSFETs. One of the important blocks that we have used is PLL. PLL algorithm synchronizes generated power of the inverter with the grid. FPGA-based 3-phase inverter control system, photovoltaic power generation. This is the block diagram of the real-time simulation that has been implemented on FPGA. The analog circuitry has been implemented in Myrio, and the digital circuitry has been implemented in Serio. Literature review. This is the literature review that we have get from different resources like research papers, articles, and websites. We have used the sine pulse width modulation technique for the MOSFETs. We know that several inverters use MOSFETs and IGBT at the input stages. We have used in this project the generic MOSFET. And this is actual the grid-tied inverter diagram, and the power generated from the solar panels and power get from the grid as synchronized with net metering system. methodology. We had first of all designed the digital circuitry and multisim, that's high voltage circuitry. This is S1, S2, S3, and S5. These are generic MOSFETs. IO1, IO2, IO3, IO4, and IO5 are signals, PWM signals to the generic MOSFETs. Line A, line B, and line C are the output line currents. And similarly, the VA, VB are the output voltage currents of all three phases. This three-phase supply has been taken from grid. We have considered that we have taken this supply from grid for the synchronization purpose with the inverter. And this is the filter in order to filter out the output waveforms of voltage from inverter. This is the co-simulation at the LabVIEW control that has been implemented in LabVIEW, and co-simulated block has been imported from a multisim in the LabVIEW. This is the control panel in which we can control like PLL gain, KP gain, and K speed, and carrier frequency, and carrier amplitude. We can directly run from the control panel or front panel the simulation, and we can directly also stop the simulation from control panel and front panel. Actually, we have designed this environment for as a user interface. Methodology. We have also implemented this circuit, this inverter on real-time simulation in field lab. This is the real-time simulation block diagram, which shows the unparalleled approach of system simulation that includes the all dynamic between the analog circuitry and the FPGA control logic. It enables early evaluation of system performance as well as saves simulation time and prototyping cost. This is a real-time simulation of inverter parameters like carrier frequency, reference frequency, amplitude, and DC input voltage that can be controlled and changed from here. This is the comparison technique that we have used. One is a carrier wave, another is a reference wave. Actually, the carrier wave has much higher frequency than the modulating wave. Both waves are compared in order to generate the SPWM signal, which has been given to the generic MOSFETs for switching purpose. This is the output current of inverter, which has been taken from inverter. And as we know that inverter current, gives an alternating current. This is the inverter output voltages, and this is the gate voltages. As we know that a gate type inverter converts direct current DC into alternating current AC, suitable for injecting into electrical power grid, normally 120 RMS at 60 Hz or 240 RMS at 50 Hz. Gate tie inverters are used between local electrical power generation, solar panel, wind turbine, hydroelectric, and so on. This is the results from FPGA or real-time simulation that we have done in field lab. These results are with filtration and synchronization. When we have used filters in order to remove the ripples from output voltage waveform, and when we have synchronized the output voltage waveforms and current of inverter with the gate voltages. This result shows that before filtration, there is a fluctuation in voltage waveform, and there are also harmonic of DC, or we can say the DC components in output voltage waveforms. After using the filtration, we can see that there is no DC component, there is no fluctuation in voltage waveform. It's smoother and very fine waveform. Conclusion: in this project, a LabVIEW Multisim co-simulation platform was presented for designing control algorithm that could be used to run circuit design in multisim and provide the simulation results. Once the simulation results are verified, the same algorithm can be loaded to NI controller such as NI Stereo or Mario and the real-time controller can be used to control the real-time result in FPGA. Therefore, the use of this platform allows the obtaining simulation result and does not require changes to the code for real-time application. Design and implementation of grid-tied inverter has been presented. Result confirms that GTI is capable of producing an AC waveform that is synchronized with grid. These are our future recommendations. High voltage direct current modular multi-level inverter. We will take this inverter to the multi-stages. We will also commercialize this inverter for industries and homes. The main focus area of our project is the increasing power density and reliability, improving the efficiency of overall performance of power inverters. We will be also working in future on these recommendations. These are some references. These are the video links